Alright guys, today we're going to do the last new thing of the entire year for pre-cal, and this is the quotient rule. Now the quotient rule is very similar to the product rule in that it helps us to find the derivative when I have a function divided by another function. Okay, so we use the product rule when we're trying to find the derivative of two functions multiplied together. This is when two functions are divided by each other. And the quotient rule is this whole thing right here. It's a little longer than the product rule. And it's going to be a little bit tougher because the order here is going to matter, because instead of a plus, I have a minus. Alright, now the easiest way to remember this, what we like to say is that we have a high function, and we have a low function. So the way we remember the order at the top here, it's low d high minus high d low. So because it's the low function, then the derivative of the high function minus the high function times the derivative of the low function. So low d high minus high d low, and that's the top of the quotient rule. Alright, so if we were going to use the quotient rule here, we would start off, we would follow the exact same formula. So low, take the low function, times d high, so the derivative of the high function, which using the power rule is 2x, minus high, times d low, derivative of the low function. And it's all over the entire low function squared. Now again, for today, if you want to just leave it at this step, that's okay. You will have to be able to simplify these though on your quizzes and tests. But for today, just to get used to the quotient rule, if you want to leave it here, that's okay. Now one thing to be careful about, just because you know the quotient rule, you don't always have to use it. There are a lot of cases that it's going to be easier not to use a quotient rule, like this next example, 3 over x to the fourth. Instead, I could use the quotient rule and I would get the right answer, but it's going to be a lot easier if I realize this is the same thing as 3x to the negative fourth. We've already been solving that question. To find my derivative, all I have to do is use the power rule. And then I can rewrite that as negative 12 over x to the fifth. Same thing here. Okay, I could use the quotient rule, I would still get the correct answer, but it's going to be a lot easier if I remember my exponent rules. Okay, so remembering exponent rules, if I have the same variable and I have it on top and bottom, I can simplify that by subtracting the exponents. So this equation is the same thing as 4x to the 2 minus 2/3 power. Then if I get a common denominator there, that's 6 over 3 minus 2 over 3. So instead of that function that looks that way, I can just rewrite this as 4x to the 4/3. Then if I want to find my derivative, I can just use the power rule. So I multiply by the exponent, and I subtract 1 from the exponent. I know the 1/3 power is the same thing as the cube root. Alright, now my next question uses that property we talked about actually last week when we were looking at the product rule. So if I have a constant number multiplied by a function and I'm trying to find the derivative of that, it's the same thing if that constant number is multiplied by that derivative. Okay, so we did this when we had that example with the 4 cosine x. That derivative was the same thing as 4 times the cosine of x. That's what we did on the product rule. So we're going to use that same idea here. Okay, my derivative, if I want to find the derivative of this function, okay, I want to find the derivative of this whole thing. But if I don't want to use the quotient rule, I can take that constant and multiply that constant by the front. And the constant I have multiplied by here, if I'm dividing by 5, that's the same thing as multiplying by 1/5. So what I can do is I can take that 1/5 and move that to the outside. So I can do 1/5 times the derivative of this function. And that's just a normal function again using the power rule. So I can rewrite 3 times the square root of x as 3x to the 1/2. And now I'm going to find my derivative. So I have 1/5 times, and then following my power rule, 3 times 1/2, subtract 1 from my exponent, minus 2. And then again, I can rewrite that negative 1/2, that's 1 over the square root of x. So I have 1/5 times 3 over 2 square root of x minus 2. Alright, now the last one we have on here is probably the most difficult one you would see with the quotient rule. Okay, so if you look, this is one we will have to use, knowing what we know right now, we're going to have to use the quotient rule here. Okay, so I have a function on the top and a function on the bottom. I can't really get away with this until I learn more about the derivative of cotangent, which we have not learned yet. But what we're going to do here is follow my quotient rule. Okay, so if I want to find the derivative, write it where there's more space. It's going to be the low function times the derivative of the high function. And this is where it gets a little tricky. Okay, so the derivative of the top function, I have a function times a function, which means in order to find that derivative, I'm going to have to use the product rule. Okay, so in order to find the derivative of x squared cosine x, I need the product rule. So the product rule would be the original first times the derivative of the second plus the original second times the derivative of the first. So everything in yellow there is just my g prime, or my f prime. So that's just my d high. So there's the f prime, and then 3 sine x, that was just my g. So there's my low, there's my d high. Now I need my minus high, so the original high function, and then d low, so derivative of the low function. And we know the derivative of 3 sine x, derivative of sine is cosine, so that's going to be 3 cosine x. And that's all over low squared. And if I square the whole bottom, I square the 3 as well, which gives me 9. And remember, when I square sine of x, I'm not just squaring the x, I'm squaring the whole thing. So it's sine squared of x. Now again, this is one that we really could simplify, actually a decent amount, because if you get your sine squared and your cosine squared. But for now, today, just to get used to the quotient rule, we'll go ahead and leave it like this. And that's all there is for derivatives, guys.